Hello everybody and welcome to the House of Builds. Today we're going to be doing simple automations. Today we're going to start with an automated door with motion sensors. Give you a little test here. Now this setup works great other than you need a square above it and you can't drop any items in view of the sensor. If you drop something in view of the sensor, it'll open the door. Just give it a little kick. Pick it back up, and it'll close the door. Now to do this setup, we're going to need 2 logic readers and 2 logic writers. So the first one, we're going to set the variable to the sensor interior and the activate. Then we're going to write from this reader to the door. And out will be door and open. Then we need to do the same with the hallway sensor. Sensor, activate, reader, hallway, and then door and open. Now, to get away from having to have a square above or have something drop on it, you can just use trigger plates. I find these almost work better. There's one hidden underneath this panel in front of me. I'll show you the IC code for this, and this can also work for the motion sensors instead of having plates. So you write your registers to your devices, your plates and your door, and we loop, yield. I always put a yield at the beginning. Then you want to load register 0 from device 0 setting. Same with the second device. Then you want to add them together. And when you add them together, it'll either give you a 1 or a 0, because 1 will be 0 and 1 will be 1 at all times. Or both will be 0. And you want to write that to the door. And then jump back to the loop. This also works great for the airlock doors because they don't have a button on them. So you can just walk right up and okay. Now in the next room, we're going to be doing some arc furnace automation. Pretty simple stuff. We'll start with the logic side. Now this is pretty simple. You will need 2 slot readers, a logic writer, and a compare. You want to read the arc furnace with the import slot and occupied. Then you want to read the arc furnace with export slot and occupied. Then you want to compare the two. You want to make sure that the import is greater than the export. Then you want to write it to the logic writer. Write from the compare to the arc furnace and activate. You want to put a chute system on it. We'll give her a little test here. Throw a piece of iron in. Now I do it this way because you can jam the chutes if you activate while it's still trying to export. Now to show you the IC side. So we're going to set our device with an alias. Then we loop. Then yield. Then we want to load register 0 from a slot, so LS, from device 0, and 0 is your import slot, and occupied. So we can turn on the device by saying the slot is occupied. We'll just write that occupied number right to the device as it's on. And then we will load our second slot, the export slot, Load register 1 from device 0. Slot 1 is your export and occupied. Then we use your select, which is like your compare chip. And we want to load that to register 2. And if register 0 and register 1 is greater than. So if register 0 is greater than register 1, then it'll read a 1 on register 2. Then we'll write that to the activate of the arc furnace. And jump back to loop. Give us a little test and see how we put it in. It'll automatically turn on and activate. And with the magic of video editing, we'll just fast forward through this till it's done. And it kicks it out. Next, we'll work on some chute bin automation. You can put stuff in the chute and it'll automatically close. Now this one's a little more confusing. To keep it open, you need to write a 1 to open, and to close it, you need a 0. So you need to reverse the occupancy from writing to the open. And to do this, we're going to need a slot reader, compare unit, a memory, and a logic writer. So on the slot reader, you're going to write from the chute bin, and the input and the variable is occupied. And then you want a memory with 0. And you're going to compare the slot reader, and if it's equal to 0, that way if it's something in it, if it's a 0, it'll read a 1. And then you just write that to the compare, to the chute bin, and open. We'll just give her a quick little test here. I find doing it with logic chips is a lot smoother of an animation. When you do it with IC, it's a little choppier of an animation. And this one will also turn on the chute bin when something gets put in. Now the code. So we need to set the device to the chute bin on device 0. Then we need a loop start program, then yield. Then we want to load register 0 from the slot of device 0. So 0 is input and occupied. And then we're going to use that number to turn on the chute bin. So device 0 on, and then our register from being occupied. Then we want to select is equal to 0. So if R0 is equal to 0, it'll write a 1 to R1. And then we want to write that to the open. And then jump back to loop. But like I said, it's a little bit choppy. Next, we're going to do some heat control and some gas pressure control. So now we're going to do a wall heater and a wall cooler setup. With logic chips. And they're pretty much the same setup, just reversed. So we're going to need a logic reader, a logic writer, a compare, and a memory. So on the logic reader, we're going to need the sensor and the variable temperature. Then we want to compare that to the memory, and we want to make sure it's less than the memory, which the memory is set to 294 because everything's in Kelvin. And then we want to write that compare to the wall heater and turn it on. The 294 is 273 is the conversion. So you want to minus 273 from that number to get Celsius. Wall cooler is pretty much the same setup. Logic reader, logic writer, and a compare, and a memory. Except for on the compare, you want it greater than the temperature, and it'll kick on the cooler. Again, it's in Kelvin. 292 minus 273, 19. That way this will keep this room between 21 and 19. And then you want to write that out to the cooler. Another thing I would like to say is these active vents don't get enough love. They have a pressure sensor built right into it for the room, and it will only export gases until the room reaches 101.3, and it'll suck in gases until the room is at 0, and then it'll go into standby mode, and it'll still be on, but it won't be doing anything. So they're way handy for pressure control. Okay, next will be the IC setup. This will be both of them together. So you got your sensor, your heater, and your cooler. And I like to make sure they're off at the beginning of my code. When the code first activates, it'll make sure that those things are off. So your device 1 is on is 0, and your device 2 on is 0. Then we go to loop, then our yield, and then we want to load register 0 from device 0, and we're going to read the variable temperature. Then we want select less than. So if R0 is less than 294, it'll write a 1. And then we want to write that S to the device 1 on, and then we'll use that register 1. And then if the temperature is greater than 292, then it'll write a 1 to the R1 and turn on the wall cooler. We'll write that after and loop. The next ones are just the wall heater and the wall cooler by themselves with IC. And they're super simple. Basically just half that code put together. Same thing. So yeah, it's basically the same thing. You want to just load your temperature, select less than, and write it to the heater. And the wall cooler is pretty much the same, except for it's greater than. So sensor, cooler, make sure it's off. Loop, yield, load the temperature. Select greater than 292, register 0 is greater than 292, and then write it to the cooler. And loop. Last thing I'm going to show you is some pressure control for dump stations and refill stations.
Filter low.
So we're going to need a logic reader, a logic writer, a compare, and a memory. So you want this set to the drain canister storage, and you want to read the pressure on it, not the tank, but the canister fill. Then you want to compare it. That chip is greater than the memory, and the memory is set to 0. So at 0, it'll turn on the volume pump. So you want that compare out to the volume pump and on. And that will automatically, as soon as you put something in there, it'll suck it right up. Boom. While this is filling the tank, I'll show you the fill. Now, you should put a can in the fill at all times when using this logic, because it'll just constantly keep the pump on until the pipe explodes. So you want the canister with the variable pressure, and you want to compare that reader is less than the memory. And the memory is set to 5,000. Then we want our logic writer. I'll turn that on. I'll put a can in it here in a second. See how it automatically turned it on. So if you take this can, and we'll put the can inside the thing so it has something to read. And now it'll fill the can until it's above 5,000. And it'll turn that pump off. Same thing with the IC. It's basically the same things. You have your dump tank, your dump pump, your fill tank, and your fill pump. You want to make sure those volume pumps are off. Then we got our loop, our yield. Then we want to load register 0 from device 0 and read the pressure. Then we want select greater than 0. So it'll write a 1 to register 1 if R0 is greater than 0. Then we want to write that to the dump pump. And then load register 0, because we can throw that a first register away and reuse it. And read the fill tank and pressure. And then we want select less than R0 is less than 5,000. And then we'll write that to register 1, turn on the pump to register 1, and loop back to loop. They are pretty simple setups. And this will just keep going until this is full. Throw a tank into this one. Turn it on. And then I'll start filling. And we'll just... There we go. Yeah. All the automation is pretty simple. You can join me in Discord if you have any issues. I'll post a link to my Discord down below. Make things easier on you. And yeah. Thanks for hanging out, guys. Hope this helps you figure things out. Catch you next time.